As an attendee, you've probably walked the exhibit floor already, or if you're watching this before the show and you want to take advantage of the registration discount, just put in video into the coupon area and you'll get a discount. Now, during the show, you're probably going to be attending classes or birds of a feather sessions or whatever. Well, the internet being provided to you in the classrooms and meeting rooms come from these units, these half racks. Again, everything's built around the concept of quick deploy. So in the meeting rooms and so forth, we'll actually connect up these switches to data jacks within the venue, or sometimes we'll roll out long rolls of cable and run it into the classrooms and so forth. But the concept is it can fit into the smaller cable closets that exist in a lot of convention centers, especially around the areas of the meeting rooms. We call this off-show floor. These off-show floor PEDs, or pedestals, equipment racks, this PEDs actually is a term that harks back to the very, very beginnings of Interop, back in an old restaurant in Monterey Bay, where a whole bunch of engineers just got together and said, gee, I wonder if my equipment will even talk to yours. And friends being friends got together in this restaurant, put them on bar pedestals, you know, those little small tables that you might see in a bar. Equipment just went on that and everybody plugged it in. Wow, the concept was great. Some of the equipment couldn't even be purchased yet because it was still being designed. So the pedestal was born. We've taken that, we've now put them on racks, we roll them in. The volunteers will actually roll it into the cable closets, roll them into the classrooms and so forth, so that we can quickly deploy. Everything's pre-configured. All we have to do is plug it in and go. Well, it's a great concept. Sometimes we bend a few wheels, sometimes it's a little harder to push, but that's all right because it's still better than having to take the switches, put them into the closets, get the switches mixed up, perhaps try and reconfigure everything, make sure everything works. No, quick deploy. Everything just clicks into the back. We actually have quick disconnect panels so that the cables coming from the classrooms just short patch cable right into the back. We don't have to unpatch anything, so that, say, specially configured ports for the wireless, in this case Xeris, can be fed power over Ethernet if that's the case, or perhaps telephones, and they might be in the VoIP VLAN. By being able to pre-configure this, the amount of time it takes to light up the network and start providing services is greatly reduced. So, off-show floor. Let's go take you around and show you some more of the InteropNET as it's being built in the InteropNET warehouse. We call this hot stage. What I have behind me are equipment PEDs or racks. We call them PEDs, short for pedestals, which harks back to the very beginnings of the InteropNET. Well, it's all about quick disconnect, quick deploy. So one of the things you see is lots of cables that seem to be going nowhere. Well, that's because what goes into this upper area are patch panels. The ribs, which are bundles of Cat X cable, are hung from the ceiling, and this, by the time it gets down to the patch panel, it's a big thick bundle of 48 cables. So we drop off each set on what we call a biscuit. It's actually a 2-port wall jack that's actually zip tied into the cable bundle. Well, the ribs stretch out over the show floor. We actually plan out the paths and distances on our CAD drawings, and the electricians will lay them out from the messenger cables or from the rafters. Now, at the very end of the ribs are these 48-port patch panels. So we actually only use the numbers of the top row, 1 through 24, and we call it 1A, 1B, 5A, 5B, and so forth and so on. Well, we will then patch it in. These cables will take a connection and plug it into the patch panel that then goes over the ribs, hit the biscuits. We put tails on that. Actually, the electricians put the tails on them, and they drop down into the booth. This allows us to lay out the cables, the cable backbone, before anyone moves into the trade show venue. So with the empty floor stretching off into the distance, the electricians will be going around on their forklifts and snorkel lifts and lay in our cable plant. Then as the booths get laid in, the electricians then drop the cables from the ceiling, and that's how the booths get connectivity back to these equipment racks. The equipment racks are then connectorized together on quick disconnect assemblies to be linked together and then back to the NOC. The gigabit Ethernet connections from Quest are then sent into a communications closet in the convention center, into our routers, brought up through the infrastructure on a fiber optic umbilical into the NOC, and then distributed out to the show floor. It also distributes out to the from the router out to switch networks onto the off-show floor to provide telephony to the meeting rooms and offices, media room, and so forth. But more importantly, everything is quick disconnect. Even our fiber optic system by Systemax. It actually has ribbonized cable on a teeny tiny little connector. The ribbonized cable is polished and allows us to plug into patch panels. Just click and you've connectorized 6 pairs. Click, another 6 pairs. Each of the green cables that you see on the show floor actually has 4 of these, 4 sets of 6 pairs. So the cable has 6 pairs of single mode, 6 pairs of optimized multi-mode, which is the 50 micron, and 12 pairs of standard 62.5 multi-mode. It allows us to very, very quickly connectorize our backbone. In fact, we usually have our backbone lit up within hours after showing up on the show floor venue. Once the racks are on the floor, the fiber's pre-hung by the electricians, we connectorize it in, power it up, and we are live. Well, maybe not, because a lot of what's involved with the InteropNET is about testing. The InteropNET might be a really big network, but there's a lot of smaller networks connected to it during the show. They're in the vendor booths, and we don't have any control over those. So one of the things that we do is we do lots and lots and lots of testing. We need to be able to trust our network so that when these foreign networks connect to us, we at least have a basis to go and start our troubleshooting. Well, a lot of the troubleshooting is done with the equipment in this case. We call this our Fluke case. It's basically a big travel case with lots of drawers, and we have all the various Fluke equipment in here. We've got cable testers. We'll actually go and find out, is the cable meeting the correct specs? Do we have too much noise? Maybe someone goofed and we laid some cable too close to one of those high pressure sodium lamps. Well, in that case, it'll show up on the Fluke DSP, the cable testers. The cable testers allow us to go and find out, is the cable crushed? Is it too near to some lights? It's all about testing. The next layer up, we start testing out to the Ethernet, making sure things work. The Fluke Net tool is great for that. It's nice and portable, easy to carry around with the team. They'll actually go into the booth and test. Can they get out to the NOC? Can they see the critical services? And of course, once we have the externals connected up and everything's running, they'll actually use the Fluke tools to ping out to the net. Now, I told you a little bit about the critical services. Some vendors have some critical services as part of the demo. They need to be able to have a minimum amount of bandwidth, or at the very least some guaranteed priority on their bandwidth so they can get out to their demos. Well, in that case, we'll actually run synthetic traffic over our connections to make sure that the actual technologies, the actual port numbers, the actual type of traffic that the vendors are going to be using has been tested out to the world. Unfortunately, we only control the network up to Quest. After it leaves the Quest domain or the Quest network, we have very little control over it. So what we do is we try and go and say, hey, if they were going to say this continent or that continent or this part of the USA or that part of the USA, let's go and test. Find out, can we get to it with a sustained amount of traffic, simulating the technology that the vendors actually need. So Fluke's all about that. We have servers placed all around the United States and in some cases in foreign countries that allow us to run those synthetic streams. Fluke Networks is our troubleshooting partner, and this is Brian Chi with the InteropNET.